All right, so these are the notes for graphing rational functions using RATEY. Okay, so these are the steps you're going to take. It's called RATEY, R-A-T-E-Y, and let's kind of go through this. And please do pay attention because this is very helpful. So this is the process we're going to use to graph all rational functions in this class. So the first R stands for roots. So the solutions are on the top. So right here it says, these are the x-intercepts, set the numerator equal to 0, and solve. Write the answers as points, number, comma, 0. So your roots come from the top, okay? You need to know this part right here. These are your x-intercepts. The roots are your x-intercepts. Set the numerator equal to 0 and solve. You may have to factor it, or maybe the quadratic formula, but you set it equal to 0 and solve. If you have a number at the top and no variable, there are no x-intercepts. Okay. All right, so asymptotes. These are your vertical asymptotes. These are the vertical asymptotes. Set the denominator equal to 0 and solve. Write answers as lines, x equals each number. Okay, that's pretty straightforward. After that, we have the T togetherness. Now this is the one, I don't think it's too difficult, but sometimes people do struggle, so please pay attention here. So together is the special squared term. So you have two types of terms. You have ones that are squared and ones that are not. So examples. Together, special squared terms on the bottom means groups will come together at the asymptote. So what does that mean? If you have x squared, they will hug the asymptote, okay? So you have to look like this on the bottom. X squared, negative 2x squared, x minus 5 squared, x plus 3 squared. If you see something like that on the bottom of a fraction, they hug the asymptote. So what does that mean? So here's an example. Here's my vertical asymptote. If they're squared on the bottom, they hug that asymptote. So from both sides, they're squishing it together, kind of, it looks like they're hugging it, right? If it's not squared on the bottom, then they're not hugging it. So what does that look like? Well, like let's say this is your graph right here, here's your asymptote. Then they would be going, like one would be this way, and the other would go away. So they're not hugging the asymptote together. Like this one, they're hugging it. Here, they're not. Okay. Now, how do I tell the difference? Well, it's got to look like this to hug it. These, you'll notice, there's a plus sign, but there's a plus sign over here. What's the difference? Why are they not the same? Because that's actually very important to understand. Parentheses. These are in parentheses, which means they're connected. This is not in a parentheses, so they're actually like separate terms. This one has one term, this one has two terms. So that's the difference there. Good catch. And as we get through examples, I'll kind of talk about that with you as well. So we have roots, or x-intercepts, asymptotes, vertical asymptotes. T for togetherness. Are you hugging the asymptote or not? All right, in behavior. So in behavior is kind of what we talked about before. Is it top heavy, bottom heavy, or are they the same? So this is you look at the exponent, right? So it says, this shows how the graph looks at the ends. To the left and right, write out the first terms, use the degree of the top and the bottom to decide which category it falls into. So I always do top heavy first. If the higher power is at the top, so example, let's say you have x cubed over x squared, there is no horizontal asymptote. If your power is biggest on the bottom, x to the 5th over x to the 10th, y equals 0. Okay, so you got to look for where is that power the highest. Is it on the top? Is it on the bottom, right? Now, if they're the same, take the coefficients of the highest degree terms and you write it as a fraction, which could reduce to a whole number. So you just divide them. Take the coefficients of the two leading terms, divide it, and that's going to be it. Like, so y equals 3x over 2x, which is 3 halves or 1.5. Now, y-intercept is something we've already talked about. The y-intercept, you take 0, you plug it in for x, you simplify it, and y equals that number, 0, comma, whatever it is. So right here, plug in 0 for x. Okay. Now, I know I went through that kind of quick. When I get through the examples, I'm going to talk about each one and how do you actually do it. So I think on the back of your page, I printed out this whole little paper for y'all to look at. And now I will go in through each part of these together. So please pay attention because this is where it gets important. If at any point you have questions, ask. Don't hesitate. So these are the steps you're going to take to solving these. So the first thing you're going to do, you're going to find the excluded values. Now, so we're looking at this problem here. First off, the bottom has to be factored. So I don't actually have a piece of paper here. So right here, you see this 2x plus 6? Can I factor that? What can I factor out of 2x plus 6? What's the GCF between 2x plus 6? Somebody said it. 2, right? They're both factorable by 2. So what we're going to do is, I'm going to take a 2 out of the denominator. So I get 2 times x plus 3. Any questions on that? So, excluded values, if you recall, what number makes the denominator 0? So, I'm not really worried about the 2. What number plus 3 is 0? Negative 3. So, my excluded value is negative 3. Questions? Now, simplified equation. We're going to put the x plus 2 on the top. Does anything cross out on the top and the bottom? No, right? There are no common factors on the top and the bottom. So my simplified equation is x plus 2 over 2 times x plus 3. Questions? And the last thing, holes. Remember, in order to have a hole, something must cross out on the top and the bottom. Does anything cross out on the top and the bottom? So my holes are none. Questions on that? Okay, now we're going to get to the RATEY part. So in order to find your roots, we are going to take the function. We're going to set the numerator equal to 0. So my numerator is x plus 2. We're going to set that equal to 0, and we're going to solve. If I set this equal to 0, what do I do to solve it? Minus 2, so we're going to subtract 2 from both sides. X equals negative 2. So my x-intercept is negative 2, comma 0. That's my root. Set the numerator equal to 0. Set the numerator equal to 0. Okay, asymptotes. We set the simplified denominator equal to 0 that has an x. So for this one here, we're going to look at this right here. We have 2 times x plus 3. The only part that has an x is this part right here. So we're going to take x plus 3, and we're going to set that equal to 0. So when I solve this, I would subtract 3 from both sides. So what does x equal? What does x equal? Negative 3. Set the simplified denominator equal to 0 and solve for x. All right, togetherness is it's a question, it's either yes or it's no. So what we're going to do is we're going to look at the simplified equation. Do you see an x squared at the bottom? Yes or no? So togetherness is no. All right, next thing, in behavior. So the in behavior is actually your horizontal asymptote. So let's go back to the problem. Where is the degree highest? So I'm going to actually look at the original problem. We have x to the first here, and we have 2x to the first. Which one has the higher power? The top, the bottom, or are they the same? You all tell me. Where's the highest power? The top, the bottom, or are they the same? They're the same. When they're the same, we're going to divide it. We're going to take the leading term on the top, x, and we're going to divide it by the leading term on the bottom, 2x. What is x divided by 2x? 1/2. So for this one here, my horizontal asymptote, y equals 1/2. All right, y-intercept, x equals 0. So you're going to plug in 0 for x. You know, maybe write that better. Plug in 0 for x. Oh, sorry about that. Thank you. So we're going to plug in 0 for x. So I'm going to go to my original equation. So y equals, so on the top it's 0 plus 2. On the bottom it would be 2 times 0, which is 0 plus 6. Okay, any questions on how I did that? 0 plus 2, 2 times 0 is 0, so 0 plus 6. So 0 plus 2 is 2. 0 plus 6 is 6. What is 2 divided by 6? It's not 3. Try again. 1/3. There you go. Good job. So my y-intercept is 0, comma 1/3. And now, last thing, all we do, we just graph it. Okay. So I'm going to graph this in red. Actually, I'll do it in orange. Hopefully this is seeable. So watch what I'm going to do. I'm going to take all my values and I'm going to graph them. So my first one, -2, 0 is my x-intercept. So let's go ahead and graph that. My next one is, oh, sorry, thank you. Let's see. I have an asymptote at x equals -3. And let's see, horizontal asymptote, y equals 1/2. Oh, this is going to be hard. And we have a y-intercept at 0, comma 1/3. Now, usually, those 2 points are probably going to be good enough for you to make your graph. Now, I can use these 2 points to kind of estimate where my graph is going to be. So watch what I'm going to do. If I were to connect these 2 dots, do I have anything else? -2, 0, x-intercept, x equals -3, y equals 1/2, and 0, 1/3. So if I connect these 2 dots, there's a piece of my graph. Well, we know the piece of the graph. I told you, you have to draw it where it's very close to the asymptotes, right? So this one, I'm just going to trace it and see how close it is to, I can get it. So there's that one, and this one comes here. So I know it's going to look something like this, okay? Now, togetherness. This right here tells me, do I draw the graphs together hugging the x-axis, or do I draw them away from each other? So togetherness, what do we say for togetherness? No. So if it was yes, then I would be drawing this one down, they would hug it, but since it's no, this asymptote is going to be up here, just like that. Now you could also test points to see where it goes. Honestly, like usually what we tend to do is like this is -1, -2, -3. I would test -4 just to make sure there's some point here, and that point should be all I need to graph. Now, also to verify that this is correct, I'm going to type this in the calculator just to make sure I am doing it right. So I'm going to start with the original function. So this is how you can test it, but you won't have a calculator, so you may have to test a point. And here's the graphs. So is our graph accurate, yes or no? It is, right? So you can see right here, just because of, and I only knew they were not going in the same direction because togetherness was no. If it would have been yes, then they would have both been facing down. Questions? So these are all the steps you're going to take. So let's do another one. And we're going to work through all these because these examples, as you can tell, are going to be very important. Okay, so for the first one, first we need to simplify it. So let's start with this here. So look at the denominator. Can I factor 4x plus 8? What's the GCF between 4x and 8? 4. So 4 times x is 4x. 4 times 2 is 8. Do y'all agree? Okay. What value makes this 0? Somebody tell me. Say it again. Oh, sorry. Thank you. What value makes that 0? -2, right? -2 plus 2 is 0. So my excluded value is -2. Sorry, Grace, thank you. Now, on the top, x squared plus 2x. What's the GCF between those two? X. And x times x is x squared. X times 2 is 2x. Do I have a common factor on the top and the bottom? Yeah, what's the common factor? So we're going to cross out x plus 2. So for my simplified equation, it's just x over 4. Bless you. Now, this time, do I have a whole? I do. Whatever you cross out, you set that equal to 0 and solve, and that's your whole. So in this case, what did I cross out? What did I cross out? X plus 2. So we're going to take x plus 2. We're going to set that equal to 0. We're going to subtract 2 from both sides, and what does x equal? So my whole is that x equals negative 2. Now that one's actually very useful, and since we're not getting the point, that's going to not help us as much, but we'll see if we can do it without the actual point. If not, if we do need it, I'll show you how to get it. Okay, so let me take a look at one thing real quick, and I will finish the rest of this. I'm curious about one thing. Okay. Now, roots. We're going to take our simplified equation and we're going to solve the denominator. So first off, what is in our denominator? So here's our simplified equation. Do we have an x in the in the numerator? Because roots come from the numerator. Do we have an x in the numerator? Yes, no? I'll wait for y'all to tell me. Yes, okay, there we go. So x equals 0. Can I solve that, or is it already solved? Can I solve it, or is it already solved? It's already solved. So my coordinate for my x-intercept is 0, 0. Now, for my asymptote, where is, do we have a x in the denominator, yes or no? So there is not an x in the denominator, do y'all agree? So in terms of vertical asymptotes, there are none. In order for there to be a vertical asymptote, your simplified equation must have an x in the bottom. Togetherness. Do we have x squared in the denominator? Yes or no? No. So togetherness again is no. They don't hug the same asymptotes. In behavior, where is the power highest? So take a look. This is actually pretty easy. Is the highest power on the top, bottom, or are they the same? Well, guess what? How many x's do you see in there? How many x's do you see in here? 1. And where's it at? Top. So automatically the top has the highest degree. So if it's on the top and it's the highest degree, what is my horizontal asymptote? Look at your notes. What does it say? Top heavy, no horizontal asymptote. Somebody just said that. So again, this is no HA, no horizontal asymptote. Okay, Y-intercept. We're going to take this one. We're going to plug in 0 for x. So y equals x over 4. So 0 over 4. What's 0 divided by 4? 0. So my y-intercept is 0, 0. And it makes sense. If my x-intercept is 0, 0, my y-intercept should also be 0, 0. Okay, last part, I'm going to graph all of this on here, and then we're going to verify that our graph matches this. So watch what happens here. So first off, let's see what I have. I have a root at 0, 0. And that's actually all I have. I have nothing else. Would y'all agree? Now, I want you to look at this equation real quick. Do you all know what type of equation this is? If you don't, it's fine. But does anybody know what that looks like or not really? How about if I did this? What kind of equation is that? Do y'all recall? Fraction, close. It's actually called a line, right? Do you remember this form? Y equals mx plus b. So my slope is 1/4, but there's no y-intercept, so what number goes there? A 0, right? So right here we have a 0. So if you recall slope, this is a positive 1, so we go up 1, and then we go right 4. So from my y-intercept, I'm going to go up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. To go the other way, we go backwards, we go down 1, left 4. Down 1, left 4. Now, this is where it actually gets important. So watch what I'm going to do. Do you recall when we said holes, we said there was a hole at x equals -2? Do you remember that? So what happens is when you go over here to the graph, you go to x is equal to -2, -1, -2. That little piece right there, you actually have to erase it and put a little tiny hole right there. And that's a hole in the graph. Okay. Now, did we do this correct? That's the real question, right? Like, let's see. Here's the actual graph of what it looks like. And that was ours. So what do y'all notice? Oh, I can probably turn this down a little bit. What do y'all notice between our graph and their graph? They're the same, right? 2 lines. Now the cool thing about this, I think if you drag your finger on the graph, I guess I can't see. Oh, there it is. You can't see it because my finger is actually covering it, my bad. But on -2, it usually says it's undefined, but I can't get it to stay, so, but it is undefined at that point. All right, let's keep going. We got 2 more examples. Let's see what we can do here. All right, for this problem here, the next one. So I'm going to factor the denominator. So x squared minus 2x minus 3. So I'm going to do the x method. So x squared minus 2x minus 3. So what goes at the top of the x? What goes at the top? -2. What am I dividing both sides by? And what goes on the bottom? So we need 2 numbers that add to -2 but multiply to -3. Does anybody know what 2 numbers those are? 1 and 3. So -3 and +1. -3 plus 1 is -2. -3 times 1 is -3. So this becomes x minus 3. And this becomes x plus 1. All right. Can anybody tell me my excluded values? Oh, let me keep this here. Sorry. What are my excluded values? 3 and -1, right? 3 minus 3 is 0. -1 plus 1 is 0. So my excluded values are 3 and -1. Now, on the top, x squared minus 9, I feel like somebody should be able to factor that by now in their head. So can anybody tell me what x squared minus 9 factors to? +3 and -3. So we have x plus 3, x minus 3. Does anything cancel out on the top and the bottom? X minus 3. So for my simplified equation, what's left on top? X plus 3. And what about on the bottom? X plus 1.
Sorry, I should not. Mr. Martin. Mr. Martin is so sorry.
All right, anyways, keep going. So x plus 3 on the top, x plus 1 on the bottom. Now, in terms of a whole, did we cross something out? Yes, we crossed out x minus 3. So we're going to take x minus 3, set it equal to 0. We're going to add the 3 over, so what does x equal? So my whole is that x is equal to 3. Questions? All right. Now let's go ahead and do the whole RATEY part now. So roots. So again, when we start doing the RATEY part, we're actually looking at the simplified equation. So we're looking at this part right here. So now let's see if y'all can start telling me now. Where does the root come from? Might have to use your notes because something you're gonna have to start referring to. Where does the root come from? Numerator, the top. So we're gonna take our top, x plus 3. We're gonna set that equal to 0. X plus 3 equals 0. How do I solve this? Subtract 3. And what does x equal? X equals -3. So my root, -3, comma 0. There's my x-intercept, -3, comma 0. All right, for the asymptote, what do? Set the denominator equal to 0. I actually have a denominator. I have x plus 1 on the bottom. So we're going to take x plus 1. We're going to set that equal to 0. So when we subtract the 1, what does x equal? So my vertical asymptote, x equals -1. All right, togetherness. What am I looking for on the bottom of the fraction? Okay, do I see an x squared here? No. So togetherness in this case is no, it's not there. They're not hugging the same asymptote. In behavior. So where's the power the biggest? Top, bottom, or are they the same? They're the same, right? X to the first, x to the first, those are the same. So we're going to do y equals x divided by x. What's x divided by x? 1. So your horizontal asymptote is at y equals 1. Last, y-intercept. So what do I do for the y-intercept? Plug in 0. So y equals, we have x plus 3, which becomes 0 plus 3. We have 0 plus 1, which becomes, or x plus 1, which becomes 0 plus 1. So what's 0 plus 3? 3. 0 plus 1, 1. So what's 3 divided by 1? 3. So my y-intercept, 0, 3. Now this one gives us a lot of information, so the graph should be really easy to do. At least I think it will be. Let's see. So first off, I have a root at -3, 0. I have an asymptote at x equals -1, so that's vertical. Togetherness is no. I have a horizontal asymptote at y equals 1. And then I have a y-intercept at 0, 3. And I do have a hole at x equals 3. So I know there's a hole somewhere along here, which would really help me to make my graph, but it's fine. But since I have, you can tell, here's quadrant 1, 2, 3, and 4. Since it's not together, I know this one's going to hug the asymptotes. Togetherness, if it was togetherness, they would be hugging the same asymptote up here, but they're not. And you can see this points down here, so it's going to look something like this. Now, again, we had a hole at x equals 3, so I'm going to go to 3. 1, 2, 3. I'm going to erase that piece and just draw a little tiny hole there. And again, I'm going to verify it with my calculator just to see if it's right or wrong. And there's our graphs. So you can see they do match up. Questions? Pretty easy. All right, now the last one, I'm assuming he's going to have togetherness finally, so you can kind of see what that looks like. So let's do this one as quickly as possible. So here's the last one. I'll probably run through a lot of this just so we can get it done. So in the denominator, we have x squared minus 6x plus 9. So x method, -6 on the top, 9 on the bottom, divide by 1. What two numbers add to -6 but multiply to 9? -3 and -3. So instead of writing x minus 3 twice, I'm going to write x minus 3 squared. Okay, excluded value. What number goes right here and makes it 0? 3. So my excluded value is 3. Now, the top, I can't factor it. But these are not the same, right? X plus 3, x minus 3, they're not the same, so I can't cross out. So my simplified equation, y equals x plus 3 over x minus 3 squared. Okay. Now, did we cross out anything on the top and the bottom? So, do I have a hole? No. You put no or none. There is no hole. All right. Roots. So let's remember, we're focused on this equation right here. What do I set equal to 0? The numerator, so what do I set equal to 0? X plus 3. So we say x plus 3 equals 0. Subtract the 3. What does x equal? So how do I write that as an x-intercept? Y'all tell me now. Negative 3, 0. Okay, so far, are there any questions? This is not too bad? Okay, good. Asymptotes, vertical asymptotes. Set the denominator equal to 0. Well, x minus 3 squared means x minus 3, right? So I'm only going to set one of them. I'm going to say x minus 3 equals 0. So to solve this, I would add the 3 over. And what would x equal? 3. So notice the x-intercept is a coordinate where the vertical asymptote is x equals. It's an equation. Togetherness. This gets important. Look at the bottom. I have x minus 3 in parentheses squared. Do I have togetherness? Yes or no? Yes, I do. I saw somebody nod their head. Yes, we do. And somebody actually said yes. So togetherness finally is yes. In behavior, where is the power the greatest? Top, bottom, or are they the same? Bottom is correct. Who said that? Nice job, Grace. Bottom. So if it's on the bottom, what is my horizontal asymptote? Y equals 0. Now, if you didn't catch why it's the bottom, let me kind of show you. So this x is x to the first power on the top. But when it's x squared, it's like x times x, which is x squared. So the bottom power is actually the biggest. Good catch there. And then last, y-intercept. So we're going to take in 0 and we're going to plug it in for x. So right here, y equals 0 plus 3 over 0 minus 3 squared. So 0 plus 3 is just 3. 0 minus 3 is negative 3. What is negative 3 squared? Does anybody know? What is negative 3 squared? 9. And last question, what is 3 divided by 9? Anybody? Oh, I heard 1/3? Good job. So my y-intercept is 0, comma 1/3. Now, when I graph this, you'll see the togetherness happen. So first off, we have an x-intercept at negative 3, 0. We have an asymptote at x equals 3. Togetherness is yes. We have horizontal asymptote at y equals 0. And we have a y-intercept at 0, 1/3. Now, this part is interesting. And I'll tell you why in a sec. So first off, I do have 2 points. So since this point is here, I know that my graph goes like this. Right? Now, what do you notice about the x-intercept? Did you hear that? The x-intercept is on the asymptote. So remember we talked about asymptotes? I said you can never cross a vertical asymptote, but you can actually cross a horizontal asymptote, and that really depends on the end behavior. And since we have it on the root, here's what happens. So we're going to go to that one, and it actually jumps the asymptote there, and it hugs it from the bottom now. So that's actually what happens. Crazy, right? And I'll show you the graph to confirm it. Now, togetherness. Togetherness said yes. Since the togetherness is yes, where do you think the branch is? Is it going up or is it going down? It's going up, right? They have to hug the same asymptote. So it's going to look just like this. Questions? All right, let's plug this in. Let's make sure it's right. If it is, that's going to be awesome. If it's not, I don't know what to tell you. Here we go. The moment of truth. X plus 3, x squared minus 6x plus 9. What do y'all think? All right, pretty cool. Now, in terms of that asymptote being jumped, let's take a look when we see it happen. What do you notice right there? It jumps across at -3, which is exactly what happens in ours. All right, so that concludes the notes. You should definitely keep these notes with you because they will definitely be useful.